to Tech Tuesday. Oh, they can't see us. Hello, everybody. Oh, we need to. Welcome to Tech Tuesday. They can't see us. Hello, everybody. Don't mind us. Welcome to Tech Tuesday. Stand by. Don't mind us. I got this. Stand by. I'll tell you why in a second. Don't mind us. I got this. Just go to the other. I'll tell you why in a second. Don't mind us. I got this. Just go to the other. I'll tell you why in a second. Don't mind us. I got this. Just go to the other. We're in a new location. We're back at the offices. Well, some of us are. Location. We got a few. Some of us are back in the office. And so our setup's a little different today. That's the so our setup's we're having some technical issues, but it's fine. We'll get this together. We got it.
We got some echo.
It's fine. We'll get this together.
We got some echo.
It's fine. We'll get this together.
It's not your basic standard echo. It's a. It's not your basic standard echo. It's a.
Well, this is going so today instead of diffusing fake bomb, we're going to diffuse today instead of diffusing. Well, this is going fake bomb. So diffuse on echo. So diffuse on echo.
Looks like Bayshore is. Cornwell's is out.
All right, Bayshore's on echo.
Cornwell's is out.
All right, Bayshore's on echo. All right, Bayshore's on echo. All right, Bayshore's on echo.
This would be why.
Very good.
This would be why. Oh wait, no, we don't want
Very good.
This would be why. There should be an echo right now.
There should be an echo right now?
There should not.
Shouldn't be no echo. There should be an echo right now? Right on. Shouldn't be no echo. There should be an echo right now? Okay, is the echo gone? No echo. There should be an echo right now. Okay, let us know in the chat.
Need to put in a 911 audio.
Let us know in the chat.
Echo on. Need to put in a 911 audio.
Let us know in the chat.
Echo on. Need to put in a 911 audio.
Let us know in the chat.
Echo on.
Very good, very good. Let us know in the chat. Very good, very good. Let us know in the chat. Very good, very good.
Is it coming from? I can't see where it's coming from.
We're just trying to get the engagement up.
I can't see where it's coming from.
We're just trying to get the engagement up.
Just pull it up. I'm trying to hear.
We're just trying to get the engagement up. Stand by.
Pull it up. I'm trying to hear.
We're just trying to get the engagement up. Stand by. We're just trying to get the engagement up. Stand by.
Yeah.
Stand by.
Yeah.
Stand by.
What is Zoom using for this? What is Zoom using? Yeah, that's all current.
Well, in the meantime, how's everybody's day going? I'll ask you that 3 or 4 times.
I figured it out. We're good. We're good. Figured it out. Should be good now.
There we go.
Should be good now.
There we go. Oh, now mute the computer speakers.
What the heck? I have no idea what's going on here. This should not be doing this.
Justin Bayshore has no idea what's going on here.
This is
well,
great.
usually he handles e-kids, so this is a little bit above his pay grade.
Yeah, this is very interesting.
So, you know.
That'll do it.
Yeah, we're trying to get the, we're trying to push that Echo song, you know? Can never get enough of it. It seems to be gone now, says everybody.
Looks like we're good.
Very good. Okay, don't touch it.
So we're good now?
Seems to be gone. That's what everybody says.
Back away slow.
So we're gonna go with it. Very good.
Went from echo to gone.
So I'm gonna, yeah.
Thanks, guys. Thanks, chat. So, let's dive in, shall we? Since we diffused our own bomb here. Happy Tech Tuesday, everybody. Thanks for being here. It is May the 19th. We are, like I said, a few of us are back in the offices. So we're a little bit of location switch up. A few of us are at Valentine. A few of us are other parts of the office. A couple working at home. So we're all over the place today. But it's good to have you all here. Let us know in the chat where you're watching from. If you're watching from work, we won't tell. If you're watching from home, very good. For some of you, it's both still. So let us know. And a little, just a little announcement, a little housekeeping. Next week, next Tuesday, we will not be live. We are going to take a little bit of a break from the live stream Tech Tuesday, but we will start posting some of our favorite moments, some clips from the last several weeks that we know have been helpful for you guys. We're going to start posting smaller clips throughout the week, next week, so you can stay fresh on those, and yeah, I'm excited about that. But we're going to dive into today's topic. I know we've got a lot of watching from Uganda. Dang. Zach Zolo is right down the hall. Hey Zach. Hey Zach, yell and see if they can hear you. Wait a second. There we go. So we have actually, we were chatting a little bit last week with a few of the guys and asking, what would be helpful for a topic. And one of the topics that came up was timecode, because it's something that I think a lot of people use or encounter or hear talked about, but it's something that a lot of people still don't understand. And I think what the problem is timecode is a pretty simple concept in and of itself, but it's been sort of used in so many different contexts that people get confused by it. So I want to just dive in and talk about it, and then we'll have some time for Q&A at the end. But I want to dive in and talk about it a little bit, and let me start my slides here. So let's talk about what is timecode. The Wikipedia defines timecode as a sequence of numeric codes generated at regular intervals by a timing synchronization system. Timecode is used in video production, show control, and other applications which require temporal coordination or logging of recording actions. So I mean, I don't understand what's complicated about that. It's pretty straightforward. Anything that requires temporal coordination or logging of recording or actions. This is probably why a lot of people get confused by timecode, because this is pretty confusing. A better definition I found, and this is on Resolume's, if you know, Resolume Arena is an application we use to play back media, and their support website has a better definition of timecode. Timecode is just an audio signal that sounds like 400 pigs screaming. Ultimately, that's kind of all it is. So let me give you just a little demo, and I hope this will clear up a lot of things for a lot of people just about what timecode actually is. So I have this audio file on my computer, and if you thought the echo earlier was bad, let me tell you, you're in for a treat. I'm just going to go ahead and trigger warning. This is going to suck for some of you. So if I open up this audio file, now you can't hear anything right now because my computer's not plugged in, but I've got a cable plugged into my headphone jack, and I've got two XLR outputs. So first I'm going to plug it into this speaker device here. If you plug in a cable to it, this device plays sound out of it, and that's volume control, etc. I'm just going to plug this in. So remember, timecode's playing on my computer right now. Can't hear it. I'm going to plug it into the speaker, and then you hear that?
Probably go a little louder.
Just a little bit louder. Yeah, that is what timecode sounds like. That is, as stated, the sound of 400 pigs screaming. Obviously, this isn't very helpful in this context because this is nonsense and obnoxious. But I have a different device. You can see this here. This is, all right, I'm going to turn this off. This is the Rosenthal MIF4, and it is a timecode device. And on the back, you'll notice it has an input, an XLR input, just like this speaker has. But instead of the sound of 400 pigs screaming, when I plug that same source into this, it turns into a clock. And if you'll notice, the display on this clock and the timestamp of this audio file that I have running right now are essentially the same. So we're at 1 minute 53, 54, 55, so you can see how it matches up with my timecode device here. So this, obviously, not very helpful, but this is super helpful. So that's all timecode is. I mean, it's pretty straightforward. It is, as they state on Resolume Arena's website, it is an audio file that sounds like 400 pigs screaming. So, a couple other terms you'll hear. SMPTE. Bayshore, can you switch back to the other view there?
Yeah, we can do that.
SMPTE is actually stands for Society of Motion Picture and Television Engineers. So you'll hear some people refer to timecode as SMPTE. That's actually the organization that standardized timecode. And so you'll hear it called SMPTE timecode, et cetera, but it was actually developed first for the film industry. And they needed it to actually synchronize multiple cameras together and keep some sort of timestamp on physical film. So when they're editing, they could make cuts at exact points, etc. So the SMPTE organization, or Society of Motion Picture and Television Engineers, they standardized this idea of, hey, we can use an audio signal for synchronization of multiple devices. And so basically all it is an audio signal that a computer can interpret as a timer or different devices. So we're going to dive into some of those different devices. Another term you'll hear, and the thing is, it was 1967 that
Correct.
SMPTE created timecode, basically standardized timecode, defined it. Since then, there have been several different branches and implementations of timecode, etc. The one we're going to talk about today specifically is LTC, or linear timecode. Might also be called longitudinal timecode, but LTC is pretty much this implementation of where it's just an audio signal that gets transmitted over pretty typical audio interfaces. So let's dive into some sources. So there's really two steps, and this is where I think, and a couple weeks ago we talked about signal flow, and you have sources and destinations. The thing with timecode that I think confuses people so much is there's really three steps in the timecode source. There's something that has to generate timecode. So that, zeros and ones, basically. I'll show you what timecode looks like on a waveform in a minute, but that sound, that has to be generated by something. It can be a device, it can be an audio file like I had on my computer. This device right here that I showed you earlier that has the timer on it can also act as a timecode generator, so I can assign it to a time value, and it has an XLR output, and I can use that to generate timecode. But then play back. So this device kind of does both. It generates and plays back timecode. But in the case of what I had on my computer, I had that audio file. That audio file was generated somewhere else, which I'll show you how to do that in a minute. I was playing it back from my computer. And then the third step is output. So we have to get that audio signal out. So whether it's a device that has an XLR output like this, whether it's another device, whether it's my computer and I'm using an audio interface, but all three of those steps have to happen in a timecode source. Something has to generate timecode, be able to play it back, and output it. We'll talk about examples of each of those in just a minute. And then timecode needs a destination, just like everything else. And there's three steps to this. Something needs to be input, so like this timecode device here has an XLR input. If it's a Mac application, you need an audio interface or some sort of way to get signal into the computer, just like anything else. This speaker has an audio input, but then you have to be able to interpret that timecode. So this speaker here stops on step one as a destination. It's only got an input, but it can't interpret timecode. This device can interpret timecode, and it can display it as a timer. But then for a lot of creative applications, the third step in a destination is you have to be able to lock something to timecode, whether it's media or a device, anything like that. So you need to be able to interpret timecode, input timecode, interpret timecode, and lock timecode to something. So when you talk about sources and destinations, you need all three of those steps on each side. So let's talk about some examples of sources. Like I said, this device here, this MIF4, can be a source. So we can generate timecode. I can actually switch it to timecode generator mode and assign it to a numeric value, like it's on 2 hours right now. And I can start it running. I set it to 5 hours, and now it's running. So if I plug in something to this XLR output, that will have the timecode value of 5 hours, 0 minutes, etc. running. So this device can generate and can play back timecode and can output it out the XLR in the back. Now, let's talk about what if I don't necessarily want to use this device as a source. What else can I use as a source? We can do the thing that with a lot of things is like we can play back and output timecode a lot of different ways, like just with any other audio playback software. So if you think about one thing we use on the weekends is Ableton Arena, and that does playback and output really well. And we're already using it because we're using our click tracks and different choir tracks and things on the weekends. So it's something that's already playing back. It's already handling playback of a lot of other things. So we can play back timecode and output timecode from it as a source. The problem is Ableton doesn't necessarily generate timecode. So we need to split this step out. And the way we did that was, like I showed you, how I have this wave file. So this is just a section of timecode audio with a certain timestamp that I've generated ahead of time. And there's this really nice website, little plug for LTC, elteesee.perovi.net. I think that's how you say it. If y'all want to sponsor LTC or perovi.net, if you want to sponsor, still looking for sponsors. But this software this website can actually generate timecode. So we can generate a timecode file that you can then use in any application to play back and output that timecode to a destination, which we'll get into in a second. Let me actually do this real quick. So flavor, we've got different frame rates. Again, because this was a film application, you'll see timecode referred to in frame rates and different frame rates because it's used to synchronize different film devices. I'm just going to do 30 frames a second. Even sample rate, I'm going to leave all this default. And I'm going to set my start time to, let's actually set it to, let's do 10 hours. So what you're going to notice, and this is, by the way, this is hours, minutes, seconds, and frames. Just like any clock you might see on the wall, it just has an extra digit here for frames. So when I export this, or when I download this file, and I plug it into this device here, you're going to see this device on its display, jump to 10 hours. And I'm just going to generate a 1 minute file. So it's going to be from 10 hours, 0 minutes to 10 hours and 1 minute. And that's how long this audio file is going to be. And I'm also going to say that I'm not a robot. And let's just pick which one the cars are. Does this count as a car? It's a motorcycle.
Let's find out.
I think a robot could probably do a better job at that than I could, honestly. And great. Now I'm going to download this file. And so I've got LTC at 10 hours for 1 minute, and it's 30 frames a second. So I'm going to download that. And when I play it, make sure this is set to listen. Okay. Can you go back to the close-up? There we go. So when I play this, now that jumps to 10 hours. And it runs for 1 minute. And it stops. So there you go. So that's another example of how you can split up generating time code and playing it back from a different application or from your computer. Or again, I can drop this WAV file into anything like Ableton, which I'll show you in a minute, kind of how that interfaces into things like Pro Tools, whatever audio software you use or you want to use, or even just playing it back from my computer like this. So that's kind of an example of a couple different source options you have for timecode. Like I said, you can get something that generates timecode, outputs it, plays it back all in one, like this device, or you can generate it from a website like this, get the individual audio files and play them back and output them from a different software like Ableton. Now, destinations. Again, you have to have input, you have to have something interpret it, and you have to lock something to it. So timecode isn't very helpful if your whatever software or gear or application you're using it in doesn't actually lock anything to it. So I can, display timecode on a clock all day, but if something isn't locking to it, it's not very helpful. What do I mean by that? Let me just get into a couple examples, specifically with, I'm going to show how it interacts with Resolume Arena. Matt's going to show us a little bit how it interacts with GrandMA. But we're talking about a couple different use cases for this. With this use case, we're really talking about live production environments. So if you think about what if I need multiple pieces of gear to do the same thing at the same time, right? I could have everybody, I could put a clock up for everybody and say, hey, make sure you hit go at exactly 0 minutes, 2 seconds, and 3 frames. And could try to have everybody hit go at the exact same time. You could also use a more realistic application would be MIDI triggers, so you have network triggers of different things all happening at the same time. But the benefit of using timecode is it's a constantly running timer that different gear and software can use to listen to and constantly check if the asset that they're trying to play back is at the right point in its timeline. So in terms of media and lighting, this is a great example. A lot of people will do this on concert tours or different shows. They'll have one source for timecode, whether it be Ableton or some sort of tracks, some sort of audio software, but they'll have it hooked up to their visuals, their media server, their lighting console, and so they can have a video clip play and hit an exact point in time, and a lighting console hit a lighting cue at the exact same time, constantly every time, because what they're listening to is that gear, those computers are listening to and saying, hey, exactly when I hit this time with this on this frame, do this action, and it's repeatable because it's a computer. You're not worried about human error. So let me show you how that works with Resolume Arena, and then I'll kind of hand it over to Matt and show how like GrandMA acts as a destination. But every application, gear, software, whatever, is going to do this step differently between input, interpretation, and locking. It's all going to have its own process, and so it's just important to know for your specific application, your specific media server, lighting console, Mac app, whatever it is, you have to know the specifics of how these 3 steps are handled. So for Resolume Arena, let me bounce over to this. I'll say input is pretty simple. It's basically the same as just the opposite of what I'm doing with using my computer as a source. So it's just any standard audio interface, or even the headphone jack if it acts as a microphone. That's not super reliable, but you could technically do that. But if I were to plug in an audio interface, like we use the Focusrite 2i2, it's a great little 2-channel audio interface, and it's USB right into the computer. It's got XLR input. I can just plug in anything generating time code. And if I use that audio interface in, like if I open up Zoom right now and then had that time code line output plugged into the Focusrite, into the audio interface, and selected that as my microphone in Zoom, the people on the other end would just hear time code. It's the same thing. It's no different than any other audio interface that you would use to record a podcast or play an instrument or something and record it on your computer. But Resolume Arena is able to handle that interpreting side of it. So instead of hearing 400 screaming pigs, Resolume Arena is able to do what this device does and read it out as a clock. So let me show you that real quick. So I've got kind of an example, a demo set up here. I've got a song, and you won't hear it just because YouTube and copyright, but I have this Ableton session open up, and it's just got this that WAV file, that same WAV file that I was playing earlier, just on a track. And I've got Resolume Arena in the background. The only difference here, I'm doing some internal routing on my computer, but in Resolume Arena, the way I can select my input for timecode is in Preferences, and under Audio, they have Audio Input Device. And so all my audio input devices would show up here, and if I had an audio interface plugged in, I would select it down here. And then the additional thing that Resolume Arena gives you is you can assign, because a lot of audio interfaces are multiple channels, they might be 2 or 8 or 16 channels. Resolume Arena can utilize 2 of those to lock different things to timecode. So you can set which physical input on the audio interface you want to use as input 1 for timecode, and you'll see Resolume uses SMPTE timecode, so that's where you'll see some of the language back and forth. And then I can set input 2 of my device to SMPTE timecode input 2. So that's the input side of things. That's how Resolume handles the input side of things, through the audio interface and then through just the settings here. So interpretation. Like I said, Resolume can then interpret timecode. So I'm going to play this, and there's no sound. I'm not going to torture you with that anymore. But notice this clock in the middle of the Resolume interface is now counting up. And whenever I stop Ableton, it stops. If I jump forward to another spot in Ableton, the clock jumps. So I'm interpreting timecode, so that's great. That's what I want. But Resolume isn't doing anything with this. So I've got this video clip, so let's say this is Do It Again. Resolume isn't doing anything with this. Let me fire Do It Again, and it's not actually doing. You can see my timer here, and my timer from Ableton are not the same. So I've got 1 minute, 13 seconds here, and this is on 16, 17, and I could scrub and change this. So we need to actually lock this content to timecode, and the way Resolume does that is through the transport controls. So right now this is just timeline, this is just running free, but I can actually choose a timecode input to lock this content to. And once I do that, then you'll notice my timer running in Resolume and my timer for this specific clip are synced up. And if I jump around in Ableton, if I stop Ableton, the content stops. If I go back to the beginning, the timecode jumps, or the content goes back to the beginning. If I jump around, remember that song? Jump around. Sorry. Then my content will jump around. So we input timecode, we interpreted it through Resolume, and then we locked an item, in this case a video clip, to it. Cool? There's one application. Okay, Matt. So I'm going to throw it over to you.
Present.
For lighting, for Grand MA. What are the 3 steps that Grand MA, how does it handle those 3 steps of, how does it handle those 3 steps? Oh, bay short with the echo. But how does it do input, interpretation, and locking?
Yeah, so input, it's pretty basic. So we've got a basic XLR input. It says LTC input, and that comes from wherever you're generating time code. So for our purposes, we are using it to, or we would be pulling time code from front of house, because our source is actually Ableton, because that's what we're locking everything to. But it gets to the console via just a XLR input from typically just a direct out from the console, the audio console, into the lighting console. I'm going to go ahead and share my screen here. I've got a pulled up here, so we can kind of see from the MA side of things. So we got clock here.
We're muted. Just, you know.
How I'm generating it right now, because I'm not connected to Ableton or in a Zoom, in a venue or whatever. I'm actually using MIDI time code coming from Reaper. Christian Jackson has a great video on how to set Christian Jackson is a great video. I'm gonna hit play here. I'm not gonna hear any audio, but it's just to kind of give a visual for us to confirm. So we've got time code coming in here. I'm gonna walk through how to set all that up.
I don't know how that works, but
we're going here to
right
setup. So there's a couple of things we just kind of have to configure and make sure. So we're going here to set up MA network configuration. We've got two slots. So the slot that I showed you on the back of, that was an MA command wing that we had. That's going to be slot 1. That's going to be your SMPTE time code or your linear time code. For our purposes just today, we're using slot 2, the MIDI time code. But you want to make sure these are set. You've got all kinds of, you've got 8 slots here. You just need to make sure they're configured. And if you're using on PC, this is just an on PC specific thing, you need to make sure you go to kind of your main screen, and then you're going to go to options. And you're gonna check MIDI and go to MIDI in device. So you have to have a device configured. I'm using it's a third party MIDI to basically make a MIDI loopback. So you just have to, if you're using MIDI, you have to configure your MIDI device. If you're only using LTC, you don't have to worry about that. So now let's go back and we can see time code is still working. So we got time code going on. Let's go ahead and stop that so we can actually get into what we're looking at. So we're generating time code from Reaper. It's coming in typically through that hardline input. And then we've set our internal configuration to in the settings. So now we're looking at basically how to take this information and tie it to a sequence. So we've got rattle, a sequence pulled up here. So this would be your typical sequence. So if you see, we got trigger, it's all go. So every time I hit go, it's gonna fire. It's only gonna fire on go. So how we set this, just kind of, I guess the basic standard way would be we would right click and we would set our trigger to time code, and then we would input a trigger time. So where I would get that time from is I would go in here. I've got these markers. I would select that and I'd put in this time right here. Well, that is super tedious and very frustrating and annoying to do. So what we can do is we can then, instead of basically setting these all to time code, setting the times manually, we can open up our time code pool, and then we can go ahead and right click, and then we can hit record, and then we can actually fire all of these cues. Change that to go. We can then fire all these cues, and it's going to build a a sequence for us that we can then just simply hit play. And it's going to, your cue list will eventually look something like this. So everything is locked to time code. We can then go back to Reaper, hit play, close that out. So now we can see it's actually playing. So we've got our Q1 mark, and then should go to Q2, intro A, and that's all how we can lock, essentially lock time code. Let me go ahead and stop the share. So that's how we can lock time code coming into the MA to a cue list or a sequence, or really whatever. Cue list is the primary thing that we're locking to, our sequence. So yeah, are we seeing some audio issues? Are we good there? Good with all that? Cool. So yeah, that's pretty much it from an MA perspective. It's pretty straightforward. There's just some minor config that you need to do, but it makes your life a lot easier once you kind of have everything built and recorded. You can literally just kind of sit back and hit play and watch the programming go. It's pretty nice.
Cool. So we've got, sorry about the audio issues, but they're good.
Y'all are muted.
But we got input.
Y'all are muted.
Oh, are we muted on Zoom?
There you go.
There we go. Been mute shamed. It's the worst. Cool. So does that make sense for everybody? You've got input through the XLR input on the command wing. You've got interpretation. You can see it on the timer. You can add the timer window and see that there. And then you've got locking, where you can lock your sequences. Cool. So let's do this. Let's go into Q&A. Let's see if there's anything we can ask. We had some questions come through the chat. I know, Chris, you were looking through those. You want to throw some of those out and see if we can answer those?
Yeah, definitely. So I saw Jeremy Riley sent a message saying, how do you deal with the fact that in Resolume you have to trigger a clip before SMPTE LTC will lock to that clip? It seems easy to miss the first second or two of them. So, a big thing, and Andy, you can speak into this as well, but I know with Resolume, how we build out our content, you have the linear time code column with all the content, but we also have a free will column, so that is not locked to time code. So what happens is when we're getting ready to prep for the next song or content that's coming up, we have the linear time code running with the content. When we're ready to prep for the next song, we jump over to the free will column, which will pick up right where time code left off. And so that's running, allowing us to be able to prep the next column so that on the first count, when we need to jump in with the new content or the new song, we're ready to jump into that. And all of our content is billed with a fade on it. So it's not fading right into the next video content per se. So, you're going to see, black show up at it, but it just makes it a smoother transition. So it's definitely just prepping on the front end with the content that you have, and just knowing that, hey, during this transition, we just have to know the volunteers running it, hey, be on point, listen to your counts, be ready to jump into that next column of content.
Yep. Yeah, exactly. They can't see us right now, but here we go. We're back. Yeah, definitely. So what Chris was saying is basically we are solving a problem. And actually, let me dive into this real quick, because this is a great topic to bring up. I'm going to share my screen again. And we are going to talk about something else that you can do on a lot of tools, and it's offset. So let me pull this up. Okay, let me show you why. Let me show you why this is important real quick. So I showed you an example of one song, right? So we have one song, one clip locked to timecode. Well, obviously we're going to do more than one song on a weekend. We're going to do a couple songs, and they're going to flow pretty seamlessly right next to each other. And then what we could do is use, the timecode file that I'm using is starting at 0, and it's going from 0 up to however long that song is, right? And my clip that I assigned to Simpy1 is tracking along with that just fine. So let me do the same thing on this clip here. And I'm going to assign that to Simpy1. Now notice, you'll see this, and you'll see this on GrandMA, you'll see this in a few different places, but I've got this option called offset. The problem with, if we use the same timecode value from 0 up to whatever, the length of the song, if we start at the same value every time, this is the issue we'll run into. So I'm going to have do it again, start running, and I've got it running in Ableton here, and you'll see my timer. And this is what a typical weekend, we would have our track stop for one song and start immediately for the next song as the band crashes out, pads to cover that transition, etc. So if I'm on do it again, if I'm playing that, and my timecode track is at 4 minutes 0 seconds, it runs right into the next song. You notice my timer resets to 0, and then do it again continues to play before I've ever switched over to the next song. So you see the problem there where, and if I'm on the wrong song, for instance, like the band is playing Resurrecting right now, and I'm on Do It Again for some reason, you can see the issue there is I can't define what song this is or what portion of the worship experience this is. So what we can do is actually use different sections of timecode. So like you saw when I went on the LTC website, was I could generate a different chunk of timecode and have it start at a certain point. So what we can do is actually assign certain start points for each song in our experience. But the problem with that, so think about timecode as one file that runs from 0 until however long. You can do up to 24 hours, sometimes even more, depending on what you're using to interpret it. But in our case, what we want to do is actually split it up into smaller sections and have the timecode, the timer start at different values. So 0 minutes, 10 minutes, 20 minutes, 30 minutes, etc. But the problem with that is if we have 4 elements, and each one of those, or maybe our 2-minute countdown starts at 0, 0, 0, 0, 0 hours, 0 minutes, 0 frames, and Resurrecting is going to start at 0 hours, 10 minutes, 0 seconds, 0 frames. What we would have to do, again, because you saw as the timer of my clip, or if it's the lighting sequence, the timer of that lighting sequence is going to match whatever timecode value is currently playing. So if I were to do that, I would have to have video clips that are actually that long and are just black for 10 minutes or 20 minutes or 30 minutes, which isn't very practical when you kind of dive into it. Like, it's not very practical to have a 40-minute long file, or when you get up into hours, a 3-hour long file that's just black for 2 hours and 50 minutes and then has content for 5 or 10 minutes. So what we can do to fix this is use offset. So I can tell Resolume, hey, even though you're listening to a timer that says it's at 0 hours, 10 minutes, 0 seconds, and 0 frames, offset that by 10 minutes and start the clip from 10 minutes on to there. So the way you can think about it is time code, your current time code value that's running, minus whatever offset you have set in your either Resolume or your lighting console for your sequence or whatever it is going to equal your playback position. So for example, if I have 9 hours, 11 minutes, and 30 seconds and 21 frames running, and that's my current position in Ableton or whatever software is playing back timecode, but then my offset is 9 hours, 10 minutes, 0 seconds, 0 frames, that means my current playhead for my content is going to be 1 minute, 30 seconds, 21 frames. So timecode minus the offset is going to be your playback position. So let's go back to Ableton. Let's fix that little issue that we had, Ableton and Resolume. So let's fix that issue that we had. Like I said, I want, whenever Do It Again is done running, I want this clip to stop and not do anything instead of what it's doing right now where it's restarting and playing back. And while Ableton is stopping. What you can see is it plays through Resurrecting now. I'm getting a timer for Do It Again and my content's still playing. So let's get a different chunk of time code for Resurrecting. So instead of 0 hours, 0 minutes, let's do 10 hours, 10 minutes. Or let's do 1 hour. So this audio file for LTC is going to start at 1 hour. So you're going to see when I start running this, my timer is going to start at 1 hour, 0 minutes, 0 seconds, 0 frames. So I start that, and now I've got 1 hour, 0 minutes, and it runs up from there. But if I trigger Resurrecting, you can see what it's doing is it's got my playhead all the way at the end because this video file is not 1 hour long, and so it's just at the very end of the video file, and it can't do anything. But what I can do is I can change my offset. So if I want my offset, like I said, the current running time minus my offset will equal my playhead position. So if I change this to 1 hour on my offset, then my clip will jump to 40 seconds, 41. So when I take that, you can see that my current playhead is now running at 45 seconds, 46. So my timer minus my offset, my time code minus my offset equals my playback position. So now when I am on Do It Again, if I run Do It Again, I won't see anything because that clip is not set. This clip has no content before 0, obviously, so it won't run at all. But if I go back to Do It Again, it will run just like normal. And now when I transition over to Resurrecting, Do It Again won't run at all because it is not a 1 hour long video file. It ends after 6 minutes 47 seconds. So that's how we do. That's how we handle kind of splitting up different items and using offset. So each element that's being locked to timecode can have its own unique ID and unique value, and there's no confusion over, you know, hey, we're running this song right now, but content for this song is playing. It's not even possible. And you can apply that to lighting. Like I said, you can apply that to a lot of other media applications, playback applications like that. So, cool. Let's ask some more questions. What do y'all got? Oh, Elevation Worship Resources is watching. A little plug for their channel. They've been doing a ton. Elevation Worship Resources have been doing a ton of behind the scenes and music tutorials and things like that. So if you ever want to learn how to play our songs, definitely check them out. Check out their channel. I think their channel is linked on our channel as well. So yeah, check it out.
Hey, Andy. Nick Tobin had asked, does the quality of timecode clock source affect the quality of the digital audio like workstation slave to TC's audio clock?
That is a good question. Ask that again, Chris. I think I know what you're saying.
Okay, so he asked, does your timecode to sync, or sorry, that's the other one.
Oh, okay, yeah, I see what you're saying. So, Yeah, Nathan, great question. So it doesn't, as long as whatever software or device that's listening to time code can read it and interpret it correctly, it's not going to impact the output uh, of that software. So if you're using, this is a great example. So we talk about lighting and media, but you can also lock other DAWs or other audio software to time code as well. It won't affect the output of that audio. So all it's going to do is see, hey, there's a clock running, and as long as I get the right clock, the right time value, it's going to play the audio files back as if it was playing back normally. The thing you do have to make sure of is that your frame rate is correct, and this is why Ableton and things don't necessarily lock to time code, because they don't work in frames per second, they work in samples and beats per minute. So I believe one audio or one DAW that can lock the time code is Logic. So you have to make sure that your frame rate is correct in your software. Otherwise, you'll get skips and jumps every couple seconds or things like that, because if your frame rate for your time code is set to 30 frames a second and your audio interface is expecting 24 frames a second, there's going to be a discrepancy there, and it's going to either skip those frames or duplicate stuff, or it's going to sound pretty weird. So it won't affect the quality, but it'll affect the playback performance, if that makes sense.
One question that we have is, how do we distribute time code throughout the buildings?
Oh yeah, good question. With this application with LTC, we are, and when it comes to Ableton, we're just distributing it through just normal, either whatever our audio infrastructure is. So at a lot of our campuses, it's XLR straight from the Ableton rig out to the audio interface in video control wherever Resolume is running, or straight to the audio console. We might be going through a patch bay here or there, but it just depends on what building we're in. There is another application. I don't know if we want to open this can of worms, but Kimry, if you want to speak into this, but we have another application of time code where we have time of day running in our Ballantyne location, and that's being used to sync up tons of different devices, and that's being distributed throughout the building for the switcher, for our multi-viewers, for even our computers that are locking time code. Zach, how is that all getting distributed through the building?
So here it's coming off our Ross SRG 4400 master clock. So that's also feeding reference to the entire building, LTC to the entire building, and that's where our color, our pattern generators are coming from. And that's actually pulling true GPS time. There's an antenna on the building clocking to GPS, so no computer time, none of that drift or anything. It's truly GPS satellite acquired. And so then that's coming down and then going into a couple of DA cards in open gear frames to distribute that out. Let's see, where all is it going? I made a list. So here, the building time code is going to audio. So it's going to Pro Tools and sound devices to lock all that together with LTC, as Andy was talking about earlier. And so then therefore it's very easy to marry the video captures with the audio captures as well, because Softron for movie recorder doing all the ISOs also now has LTC pulled to it. We've got audio interfaces on all of those machines to pull that data in and keep it all locked together. Tree is tracking it as well for those time of day stamps. It makes it super easy to find something if we know exactly the time of day it is, not having to try and scrub through a recording, which is why I keep pushing Living as One to give us LTC input so that we can track Bitsy and find it. But plug the Living as One if you're watching. We still want it. We really, really, really want it.
Feature requests.
I've been asking for that for too long now. Expressions tracking it for countdowns and timers and time of day reference for anything in the ticker. That Acuity's got it for time of day in it, and then all the multi-viewers have it pulled to it for time of day. You can kind of see it over my shoulder there. It's ticking away. And the nice thing about it is if it loses GPS signal or messes up, it will stop running. It's not set to free run. That way I know if there's an issue or not to go and troubleshoot that. Luckily, I think we've only ever had an issue one time, and that was when we had a power outage and it just didn't reclock. So I just was able to restart restart the master clock and it worked. And then I also have an NTP server option enabled on that so that we can point all of the computers in the building and honestly anywhere on our network to that IP address, and they'll truly be locked to GPS time as well, with very little latency based off the network.
Yeah. So I mean, y'all can see that there's so many different applications for timecode. It's not just locking gear together. Now that's one that I think a lot of people like. It's super fancy, and it's one thing that it's like really sexy to lock lighting and video content and audio playback and all that stuff too. But it's really practical when it comes to when you're doing a recording setup or when you're doing something like our live recording we did in January. We had how many cameras, Zach? Was it 20 something?
No, it wasn't that many this time. It was actually only 14.
Oh, that's right. So we've had more. We've had
a lot more.
20 something before. But even when you have more than a few cameras and you're talking about doing something that's not all ISO recorded from the same thing. So in a situation like the live recording, we have 14 cameras floating around. We don't have a way to necessarily isolate, record those all on one computer or one machine without just blowing up our infrastructure. So they're all individually capturing on their cameras. So our editors can then go in and take that footage and edit it. But you think about like trying to sync up all that content. Everybody's hitting record at a slightly different time, or if it's the same example we used earlier with trying to trigger lighting and media at the same time. Like you could have everybody try to hit go at the same time, but it's going to be a little bit different. So instead of doing that, what we do is lock all of our cameras to the same time code, time of day. They call it jamming time code to the cameras, something like that. I'm not a film guy, so I can't really speak to that. But that way, in those recordings, not only do they have the video, but they have time code value in those video clips that our editors can go in and line up every video clip based on the time code value, and they can edit from there, and everything's perfectly in sync without having to go in and line up each clip based on somebody clapping or a lip sync or something like that. So yeah, that's been a super helpful application, and again, it goes further than that with a system like the raw sync generator, where it's also generating reference and things for other pieces of gear. But let's see, a couple other questions. Could you, so yeah, Odia asks, I know you guys probably don't do it in this fashion because you're using arrangement mode in Ableton, but could you do this in session mode in Ableton too? And yeah, you could. You could technically do this in session mode and just like any other loop track or click track, you could just slice out a sample of timecode and drop that into your session view and have that trigger and just repeat and just loop, and that would loop whatever content is looping or is assigned to that timecode value would just loop with it. Gene's asking, since LTC is distributed using audio equipment, do you need to use good audio practices to distribute it? Could be close to the noise floor with running it too loud, cause problems with the signal. Yeah. You do still need to watch out for things like gain, clipping. Now, one thing, I'll show you all this. This is the last time I'm going to share my screen, I promise, but I want to show you this. I meant to do this up front, but I forgot, honestly. But look at this. I'm just going to show you Ableton. And we never did this, but if I zoom way in Ableton, all this is just an audio file that's going up, down, up, down, up, down, up, down, up, down. It's basically going to be like if you were to turn up whatever audio clip you had in Ableton at full volume, that's basically what the timecode is doing. It's going from full volume to no volume to full volume to no volume 48,000 times a second, or however, 41,000 times a second. So that's why it sounds like 400 screaming pigs when you plug it into here, but a computer sees this as zeros and ones. So it depends on what device you're using to interpret timecode, but if your device can't necessarily, if the level is too low and it can't necessarily interpret whether or not these are zeros and ones, or if it's too hot, where it's just getting slammed and it's clipping whatever device you're using to interpret it, it might not run. Honestly, what'll happen is it'll either not run or it'll jump around, which happens on weekends sometimes. it'll skip or it'll play back really slowly. It'll just act erratically. Usually that's some sort of gain issue. You can either gain it up in Ableton, up or down, or you can gain it up or down on the audio interface you're using. A few different ways to do that, but you do still need to use some best practices when it comes to audio transmission to make sure that that's not going to be an issue. Yeah, one or two more. Does your LTC for Res Limit MA come from Ableton or somewhere else? For Jeremy, yeah, it does come from Ableton. Like I said, we're generating it with through that LTC website, but it's playing back through Ableton.
It is worth noting, because I've seen some questions on here about, is Lighting using it, or when is Lighting using it, or when does Lighting use timecode? The only campus that right now utilizes timecode is Ballantine to the MA. That may change. I've been playing around with some Lewis scripts and just some fun import things, so that may change in the future, but MA and Lighting currently is not taking timecode at any of our campuses except Ballantine.
Yeah, for sure.
And even then, we really only use timecode for like really specific elements, things like that.
Yeah, that's actually a great point. Alan just asked this too, if we use timecode when playing different videos during the live stream. That depends. It's case by case. Sometimes we will. The one thing that you kind of introduce is a lot of variables when you start playing back time, like locking different playback methods to timecode. We try to avoid it when we're doing just a dedicated video that's got a talking head that you can see lip sync, because you're splitting up, audio playback and video playback, and you're having multiple sources sync up. Sometimes it can be a little bit tasking to try to sync all the content and all the devices up. There might be a frame or two difference here or there. So for something like worship visuals, it's pretty easy to adjust that, and it's not a big deal with lighting. You can easily adjust that. But for something like lip sync, that's like really important that that's spot on. And so we try to avoid that if we can. We'll do it if we need to, if the element or whatever worship experience calls for it. The general rule of thumb is that we will only use timecode for an element where the band is going to be playing back already. If it's just a video only piece, we won't try to lock anything to timecode or play it from Ableton. We'll just trigger it from a dedicated playback device and just let it run. But if we're doing some sort of creative application where we need lighting to sync up and other video sources to sync up, we will use timecode in that case. Oh, Zach, are cameras getting reference and timecode both over their SMPTE fiber cable? It's a good question.
No, we didn't buy the option for our fiber backs to do LTC through it, so we have to jam it when we do recordings. And the easiest way that I've done that is I'll drop a couple hardwired lines around the auditorium, but I'll also stand up an IEM pack, because LTC is truly pretty much just audio. So pass it through an IEM pack, and I made a cable that goes from an 1/8 inch connector to an XLR, and I can just walk around and jam the cameras very easily.
So in that case, what you're doing is you're telling the cameras for a second, hey, go ahead and listen to timecode, set your current internal clock to whatever timecode is running, and it's locked to that for a second. And then whenever you disconnect timecode, the cameras continue running from that same value, but because their internal clocks are reliable enough, they continue
Correct.
to run at that same value.
And then if the camera gets turned off, then we'll rejam it just to make sure, because it will drift. So it's at least best to give it a fresh jam when we do that.
Yeah.
And then the best audio practices, also LTC is very forgiving. I'm waiting on another DA card to come in, and full honesty, the Softron capture machines right now the 3 of them are getting LTC off of a bunch of XLR Y cables, and it's solid. LTC is very forgiving. It's kind of like LTC is kind of like reference is in the video world. You can run it for miles and it just works.
Yeah, it's very robust. So it's very rare that we run into issues. But like I said, gain is one of the most common ones, honestly. Well, thanks, guys. I hope that was helpful for everybody. I know. I mean, this is super important. Like this is one of the, like I said at the beginning, this is one of the most, I think, helpful tools in the production world, but it's one of the ones that's feared the most because people just don't understand it. So I hope today we were able to kind of decode it, decrypt it a little bit, and make it a little bit more approachable for people. There's some other things, Matt. I know you were watching, and Bayshore, you were watching some just to plug Christian Jackson. He's on YouTube as well. He's an awesome LD, and he's done some web series on timecode and how he uses it in his applications. Any other resources y'all want to point people to?
I mean, as far as utilizing it, so his video, so I use Reaper for a lot of stuff because it's super cheap. I can run it off of a USB. So I use Reaper and you can it has a timecode generator. You can just drop in the track. And so basically, on this machine right here, I can run my MA, I can run MA3D, and I can run Reaper. And you just have to have that third-party loop MIDI, and then you can generate your time code and pull it into MA. It's a MIDI code, or a MIDI. It's not a linear time code, but you can keep it all internal in programs. So I do a lot of. I don't do a lot of time code shows, but when I'm bored, or if I'm actually working on something like an element or something, and I just have my laptop, it's a super quick way to have time code, build a show, and then I can export that sequence and pull it into a file, or throw it up on the drive and pull it in. So loop MIDI, and then that video. If you just go on YouTube, we could probably post it in the description or something. But it's just, if you MA2 Reaper Christian Jackson, it'll pull right up.
I know. Cool. Well, thank you guys. Like I said, won't see you live next Tuesday, but keep an eye out. We'll be posting some clips from the last few weeks, and we'll keep y'all posted on some stuff we have coming up next. Thanks, guys. We'll see you next time.